All right, welcome back everyone. In this video, we are going to continue working with ggplot2 and talk about faceting with ggplot2. We've talked about wrapped faceting in ggplot2. There's another type of faceting which is called grid faceting in ggplot2. So grid faceting works when we want to facet our plots, create paneling with respect to two different categorical variables. So we're going to keep working with our penguins data frame. And so we were working with kind of this scatter plot earlier where we've got body mass on the x-axis and bill length on the y-axis. And we had this cluster of points that was in the upper left corner. Initially, everything was shaded the same color, and we wanted to think about how we can identify this kind of noisy cloud of points up here. And one way to do that was to introduce an additional aesthetic mapping some other categorical variable to an aesthetic. So we thought about, well, species has been a pretty important variable that has been explaining some of the different dimensions, body dimensions of the penguins. So we mapped species to the color aesthetic, and we saw that this cluster of points was from the chinstrap penguin. Another way of identifying that was through using wrapped faceting, which created three separate panels side by side, three different scatter plots, one for each of the three species. So rather than get all of the dots on the same plot colored differently, we get three different scatter plots. We could also do grid faceting. So maybe I want to think about these relations between body mass and bill length, and not just what role does species play, but what role does species and sex play? So for example, does the chinstrap, what's the distribution of male chinstrap penguins versus female chinstrap species, and so on. So here, if I choose this grid faceting by species and sex, let's think about what's going to happen. And I just want to mention that this penguin's data frame, the sex is a categorical variable. There are some penguins that are male in this data frame. There are some penguins that are female in this data frame. And there are some penguins that had a missing value for sex. There was no sex that was recorded. I'm going to remove those observations from the data frame that we're going to look at. So I'm going to create a data frame called penguins clean, which is going to have all of the observations that have missing sex values, so that the sex is coded as NA. We're going to remove those. So this first code cell is not going to print any output to the screen. It's going to create a data frame called penguins clean, which is going to just have two classes of sex, male and female, and it's going to remove the NA class of sex. So we've got three species, the Udeli, chinstrap, and gentoo, and we have two sexes that are left now, male and female. So if I do a facet grid, it's going to create a matrix of panels. The first thing I enter inside the facet grid is going to determine the rows. So I'm going to have one row for each species in this case. So I'm going to have three rows in my matrix, one for each of the species, and I'm going to have two columns, one for each of the two sexes. So I create six different plots, again, that are arranged in three different rows, one for each of the species, and two columns, one for each of the two sexes in the data frame. So this first plot that I'm looking at in the upper left, this is just corresponding to the points that are Adelie penguin, the female Adelie penguins. And this is the male Adelie penguin. So here I can compare the distributions, or at least the scatter plots, for males versus females, and I can see whether there's some distinction between the distribution of male and females for just that one species. And I can do that for each of the three species. How did the females and males correspond with each other for each of the three species? And or I can look down each of the columns and see how the distribution, or like how did the females compare for each of the three species? How did the males compare for each of the three species? So I can do all sorts of different analyses based on the sex attribute, based on the species attribute, for the comparison between body mass and bill length. So it's really, there's like a lot of dense information going on here. And if I change the ordering inside the facet grid, it's just going to change the way we align the matrix of plots. It really doesn't change the information that we're getting. It's just changing how that information is arranged. So now sex is arranged in the rows. So I get 2 rows, female and male, and species are arranged in the columns. So the first variable is going to determine each row. The second variable determines each column. And again, these variables that we facet, these should be discrete things. They can't be continuous. So they really should be categorical factor variables. They can be discrete numeric variables as well. You really don't want like a million categories here, because you're going to get a really large matrix of panels. But I think something like 6 panels, this is pretty reasonable to look at. So this is a nice overview of grid faceting. And there's another way that we could do this. Let me just run this code cell down here. It's a little bit tricky when we do it this way, since if I want to compare kind of the sex, the differences in the sex for Adelie, Chinstrap, and Gen 2, it's a bit difficult because these are on 2 different plots, and it was really convenient having them all on the same plot in some sense. So down here, it might be nice to create a plot where I've got body mass, bill length as global aesthetics, color, where I map sex as a global aesthetic to color and shape, and I just facet species. And here, this would give me like 3 different scatter plots. And maybe the goal here would be to see like, okay, for each of these species, what is the difference in the body mass to bill length association for males and females in that species. And here I've just used this scale colorblind package that we installed in the GG themes package. If you're getting an error message when you run this code cell, it's because you haven't installed that package. And if you delete that and run it, you'll get something that looks like this, that has maybe less friendly colors. But if you want to install that GG themes package, you'll get slightly more colorblind friendly colors. And for those CU Denver students, just note that these also happen to be the colors of CU Denver. We got the black and gold colors, which is a nice contrast to use on this plot. Okay, so that's a wrap on faceting and scatter plots. So that's a wrap on scatter plots as well. The next topic is going to be statistical transformations. And we're actually going to take a look at bar plots for the next couple of videos, how we can change counts to proportions or percentages, and then how we can use stacking and clustering for our bar plots when we're comparing multiple categorical variables in a single bar plot. Okay, thanks everyone.